Hello and welcome everyone for the today's LinkedIn live session, which is a very exciting topic and very important topic, that is the securing embedded devices 360-degree perspective. Joining us today are a very special guest from LDRA, that is Mr. Shinto Joseph, who is the Director Southeast Asia Operations LDRA India, and Mr. Anil Kumar, Senior Technical Manager LDRA India. We also have with us Teja, who is the Program Coordinator here in DSCI, Senior Program Manager at DSCI. So, this webinar is expected to cover what and why and how to approach the security in the context of low powered embedded devices and the role of standards in this journey. Without further ado, let's dive in. So, my first question is for Mr. Shinto. So, Shinto, sir, can you give us all an overview that why should one even worry about securing low powered devices at all? After all, they don't seem that important from a safety perspective.
Actually, you touch base a very important issue. The moment you say low power, people tend to think or believe it is less important, right? For that, I will take you back to about 35 years back, the day I joined my engineering in 1990. Those days, around about 99% of the process shipped in this world used to go to PC world. The Wintel game, Microsoft and Intel, they started the real PC game. Today, after 35 years, when I look back, almost 99% of the process goes to non-PC world, the world which is probably 100 times bigger than the PC world. So that gives you some idea about the real action or the number of processes, driving this whole world. Starting from your consumer appliances to defense systems to mobiles to entertainment, there's no end to it. Now, the moment you talk about security, there are two aspects. One is the moment a device is hacked, the whole concept of safety doesn't exist, because for safety also the fundamental principle is this: anything which is hacked, the device is not safe at all. So imagine a pacemaker you're wearing, somebody hack into that. Someone you're driving a car, someone hack into your car. It's a huge safety issue, right? Even though the trigger came from security. So this is one side. The other side is the damages that it can create, because all the end devices, which sometimes people call it edge devices or sensors, they're all actually the entry point for data collection. Imagine somewhere there somebody hacks in. You are protecting all your high-funded devices, systems, servers, but someone is already in your system, and that too through we say the strength of a chain is the weakest link. That is where it is tested. So somewhere down the line, someone gets an access, you're done with. And the world what we're talking about is starting from your banking products, your point of sales, energy meters, CCTV cameras. You're using CCTV camera to protect your home. But imagine someone hacks into your CCTV camera and keep watching whatever. In COVID time, you're seeing the live shows or the CCTV live shows, right? So it's a very interesting world. And the moment we understand, how important it is, just because of it is low power, it is not a low power case. It is a real case for people to be, concerned about it. The last aspect is there is a strategic angle. I work in the defense industry. Day one, I was been with this community, and those days I'm talking about in 90s, defense, space, nuclear. These were the only three sectors these subjects were discussed. Consumer world, hardly very few companies like Motorola, maybe Saskin, Texas Instruments. That's it. Beyond that, nobody used to discuss this subject. So today, if I look at my defense sector, that's my biggest worry. All the systems, including your guns, sensors, offensive, defensive systems, anywhere, radars, everywhere security plays a major role. And the embedded low power processors driving all these things, whether it's low power or high power, because in defense, there's no end to it. You can even have multiple cores delivering different, complex functionalities. So even at the strategic level, critical infrastructure protection, that is a big ocean. Your power, utilities, telecom networks, defense, even water distribution, railway networks, ATCs, air traffic controls. So the ocean is so big that we cannot ignore this subject, and it's so important that I think that give you an idea about a big picture. How big is the so-called low power, low devices? Thank you. You're on mute.
So thank you so much, Shinto sir. This was very great and very well explained. So as you said, Mr. Shinto, that you have mentioned that embedded devices they seem to be everywhere in our lives, even with the very basic necessity of a life, that is water distribution system. So my next question is to Mr. Anil. That can you please tell us some most common threats which can be faced by embedded devices, low power embedded devices, by us, by the defense, and by everybody else?
Yeah, thank you, Niharika, for that question. So if you say like Shinto mentioned, the embedded devices are in all the industries. So it could be safety critical, security critical industries, and even in consumer electronics. Okay. So when we were talking about security, people were thinking like this is just a myth. So security will not have any implication on safety in any way. But yeah, there are incidents where hacks had happened, and then that has led to security issues. So I can give you a lot of examples. Like for example, like in the automotive industry, I think most of you are aware about the Jeep Cherokee hack. So can you imagine like which subsystem they hacked to gain access to the car? It is basically the infotainment system. Okay, so infotainment system is like is the lowest critical subsystem in a car. The main intention is basically you use your Android, I mean, Google connection, your Apple Play connection. You use your maps and other things and all, and you also connect to your internet. But the sorry factor is that like these systems are actually connected to the same communication backbone, which is basically a CAN bus. And hacker was able to prove that like they can actually gain into the infotainment system, and eventually accessing the braking system, your steering control. So what they did was they just show the hack where a person was driving the car. Okay, and then he controlled the AC, the glasses actually. Okay, and eventually audio system and so on. And they were telling, yeah, this is not that critical. But as soon as he started accessing the brake control system, the steering wheel, and other things, the driver was panicking. Okay, so imagine like a real life scenario where such hacks are occurring, and then you can imagine like what kind of a chaos they can actually bring in. So that is one incident. In a similar way, there's a lot of other incident as well. For example, like industrial systems. Okay, so in most of the industrial system, they use PLCs, and most of these PLCs use embedded systems at the back end. Okay, and there's a common myth that like the hackers are not aware about our system. Okay, that is a myth. But it's no longer myth because hackers can actually hack into anything. Okay, so there was a case wherein like in a university in Europe, like what they did was they set up the PLC. Okay, I'm not going deep with which PLC and so on. They set up a PLC, and then as soon as they hooked into the internet, just within a couple of minutes, okay, the entire PLC system was hacked, and they were able to gain control of that particular PLC. So luckily, like this PLC was not controlling any critical infrastructures, so it was safe. So that was basically to prove that like hackers can hack into anything. Okay, so we may feel like our systems are much safe and secure, and our system is like niche. Okay, and nobody will be able to understand our system or our network. But that is not the case. Why? Because like there are more smarter people out there who can actually gain access onto our system. So there are such incidents, I mean, there are live incidents which are occurred, even the electric grid incidents, okay, chemical plants, okay, there are many such incidents which can actually occur. So these are again like safety issue which can actually be caused because of security vulnerability. And most of the time it's because like most of the systems have been designed without keeping in the mind about security. So typically they would have thought about only safety. And you can say like from a few years, most of the systems are getting hooked to the internet. So there is like a buzzword like connected. So everything is connected. So that drives its own what I say challenges. And once you actually connect your system, then basically like you're opening a can of worm. So what now will come out? What are the issues which will come out? You can only envision it. Okay. So the point over here is like there are many things which can actually come up, specifically with respect to security. And embed system is the easiest path for everybody to gain access into your system. All right. So that is something which I would like to bring it over here.
So, if I may, essentially, if I may double click on what you said, I think that's, thanks for such an insightful discussion. And you just so, do you see a pattern on some of the common, let's say, abused vulnerabilities in the context of embedded devices? Do you see a pattern that, let's say, 30 to 50% or more than 50% of devices have at least this vulnerability? Is there a pattern that you see? Is there any common things that you've seen in working with your customers and everyone?
Yeah. So the most common pattern is basically buffer overflow. Okay. So buffer overflow as well as like memory leak or illegal memory access. Okay. So these are the main reason why like people can gain access to your embed system, specifically the memory. Why? Because like your data segment is again part of a memory, and you store your data, which could be maybe encryption keys, passwords, whatnot. Okay. And a typical example for this is basically the OpenSSL issue, which was identified, right? Like the heartbleed issue. It was again based on an API where the client can ping into the API asking for the appropriate heartbeat code. But the API is not actually checking for the entire size of the data, what is the requesting. So eventually, like 64K block of data can be accessed at one go, at one API call, and the hacker can actually have multiple calls, and then can grab the entire memory, and then he can decipher. He can actually do a hex to conversion, ASCII conversion, and see like what is there in the memory, and then you can read everything. Okay. So memory overflow, buffer overflow, these are the most prevalent issues which has been identified, which is leading to a lot of security issues. Okay. Apart from that, like there are like if you are hooking, then if you have login access and so using common credentials. Okay. But again, now I think people are more smart enough, they're changing the credentials and so on. Dual point authentications, all these things are coming up. And one of the major thing is basically like people are not thinking about security as part of their development life cycle. So during your development itself, like security has to be taken into consideration. Okay. So most common is like the buffer overflows. So that like it could be array overflow, type overflow. There are many things which can actually lead into an access of your entire system.
Fair enough. Fair enough.
Thank
Thanks
you
for
so
that,
much.
Anilji.
Just before moving ahead, I would like to bring it to the notice to the audience that you can grab this opportunity and ask as many questions as you can from our experts here. So please post in your questions here in the comment box, and in the end, we'll take up all the questions. Yes, Teja, over to you.
Sure. I mean, thanks for setting the stage, Shintoji, and then essentially from there, thanks Anil for such an technical overview on what threats are being faced. If I have to ask, essentially, Shinto, for you, so what are some of the, you briefly touched upon some of the costs that these inflict, right? So what could be the impact of the vulnerabilities that are there in the embedded domain, right? Because essentially we've seen in the IT world, the moment you have a big enough vulnerability, then you have ransomware or data exfiltration and everything. But uh, embedded seems to be such a niche domain. So what could some of the impact that could be actually felt by either individuals or the companies with the vulnerabilities that arise out of the embedded world? If you can shed some light, that would be great.
Good. Actually, whatever issues, Teja, if a typical IT security breach happens, that is applicable here also, right? In addition to that, yes, we do have some more challenges. But in broadly, if you take up, we have a saying that there are only two types of companies in this world or organizations. One set of people who are aware they're already hacked in one form or the other form, and other set of people not even aware of such a thing is happening, right? Now, like in any other hacking, here also, organization's reputation is data privacy. That's one of the key issues which I'm seeing is, for example, if you are part of a GDPR ecosystem, you are not only directly responsible. Suppose you have a data leak in your organization, your customers go and sue you. That is the level of responsibility somebody is accountable today. There's a legal angle. There's a legal angle to the extent that suppose your car is hacked, and because of that repeated accidents happening, you could be sued. Your medical devices getting hacked, you are legally liable. There is a larger angle in today's scenario. If you ask me, warfare. Warfare, if you take it, modern world, the contact-based warfare means somebody taking a stone, somebody taking a sword and hitting. That has come down. It is a non-contact warfare, which we call it the information warfare, infotech warfare, and that is the one which is predominantly happening in today's warfare scenario. So, if you ask me, as a country today, the biggest threat what we have is a cyber threat. Now, in that also, the threats that could come out of hacking of embedded devices is more serious than the IT-based systems. The reason I am saying is people are normally watching IT-based systems. There are tools available. There are experts, so-called cyber experts are watching. But in embedded, what is happening is, since it is below the skin level, nobody notices it. And in general, I've seen that, okay, I have an antivirus in my organization. My firewall is taking care of everything. But actually, they don't even know that, the lower layer, people are still working. They are looking at what you are doing. So the complexity is very high. The traditional methods of tracking, analyzing don't work here. So that means, the techniques and practices, what you need to adopt in embedded would be one step further, right? That is one aspect. Second thing is the impact of future threats. For example, you many of the time today, what's happening is people hack into your system, they collect a lot of data, they do a vulnerability assessment. The real issue happens at some point of time, maybe 4 years, 5 years down the line. This I'm talking predominantly from a wartime scenario. Many countries are already seeing, their power grid going down. That too in the winter season, when an opponent decides to pull it down. We have got involved with a couple of projects like that. How these scenarios could be avoided. So, reputation, denial, legal, business implications. Yes, once imagine your banking POS device getting hacked, and repeatedly that happens, your bank's reputation goes for a toss. So there is a technical angle, there's a legal angle, and there's a human aspect, either physical or remotely. That is where I would say this whole topic for today's discussion, that 360-degree angle. If you are able to think from a 360-degree angle, I'm sure whenever you see a system, you will see this from an application perspective, you will see this from a firmware perspective, and you will also see this from a hardware perspective. And in all these areas, look at will be slightly different because as a company, now we have been doing more in the safety space. The moment we started looking security, maybe probably last 8 or 9 years. That's it. Before that, we never used to get any inquiries. I work for a company which is into 50th year this year. We are entering, and we only started seeing in the last couple of years people started talking about this particular angle, and that needs a different mindset. So that is, if you ask me, the biggest challenge is a safety guy. The way he looks at a problem, mostly he thinks my designs will take care of. But then it's because safety is more of an internal issue. Fundamentally, I'm talking about. And if your security comes in, it is mostly an external issue. Somebody trying to peep into your system. Externally, someone who is keen in doing, peeping into what you are trying to do. So we also need a mindset shift. So the last part of what I'm saying is people who are involved in this also probably should be aware that the security threat handling, people need to be trained how to be ahead of a chore. I mean, we call it, right. If you are deal with a chore or a thief, we each need to start thinking from that angle also, which is not the case in a traditional safety analysis or safety based systems.
Okay. Yeah, that's good. I mean, you've covered so many things here. But before we go on to the next question, I know we've planned the questions from the audience to the last, but I feel there are quite an interesting follow-up questions that have come up here, right? So you've briefly touched upon essentially 360-degree perspective of securing an embedded system or a product, right? So Bhakti is asking essentially what are some of the aspects to be taken care of during the development cycle itself, so that you have a
Looks
rather.
there is a bandwidth issue. Teja, it
Okay.
looks like it's getting frozen.
Okay. So thanks. I'll go again.
Can
So
you repeat
essentially,
the
thanks,
question?
Shinto. Yeah, sure. So, I mean, you briefly touched upon essentially the securing the device from a 360 degree perspective. So, Bhakti from our audience is asking, what are some of the aspects that you need to consider while designing the secure embedded systems during the development stage? If you can briefly shed some light on that.
Guys, I think it looks like there is a technical glitch.
So, am I audible, sir?
Yes,
Yeah, you're
Niharika, I
audible.
mean, we can hear you.
Yeah,
Yeah, Teja,
okay.
like,
So here we are like that. We have just covered you just mentioned that we have a 360-degree perspective in the security thing. So we are getting a lot of questions from the audience. So one. I can take we can take it here from here some of the questions. So Bhakti Dama, she is asking that which are some of the aspects to be taken care during the technology development stage. If you would like to answer this, we can then go ahead.
Anil, did you get the question?
yeah, I got the
So
question. So
Shinto,
let
she's
me,
asked.
yeah, so let
Yeah,
me
yeah, Mr. Anil.
address them. Yeah. So as far as like aspects which has to be considered as far as the development stage is concerned, is multifaceted. Okay. So why?
Anil,
Because
are
like
you able to take this question
Yeah,
to
yeah,
yeah,
we
yeah,
will
yeah,
take up.
yeah.
something
I'm,
Yeah, yeah.
going wrong again? Harry is also.
I'm answering the question, Shinto. So So when you take security into consideration, so
And it looks like,
security has to be
some
handled at
bandwidth
multiple
issue at their
levels.
end, or it could be a LinkedIn server problem.
Yeah. Okay, anyway, I'm just addressing this question. Okay, so the main thing is like during development phases, like first thing is like you need to think about risk. Okay, so if you see, like most of the industry talks about risk-based approach. So here again, like in security as well, like we may have to first start with like the cyber security risk. What are the risks? For my system? Okay, it could be internal risk, it could be external risk. Internal in the sense like my systems would be connected to internal subsystems. Okay, and external could be like once it is hooked to the internet, it can be accessed by multiple other people. Okay, so risk-based approach is one of the key aspects which has to be taken into consideration, which means risk analysis has to be done. So there are like something called as TARA, which means threat analysis and risk assessment. So that would be the starting point for any systems. And this is what has been followed basically in other industries. For example, if you take the industrial cybersecurity, they have a risk-based approach. So they start with risk-based approach, and then based on the identified risk, they'll try to make sure that the risk can be controlled. And you cannot actually negate a risk. Okay, you can actually reduce a risk. So to an extent wherein it is acceptable to an organization, which means like once you know what is the acceptable risk, then you can go and start developing your application addressing all your risk. So typically, like when you go for safety and security, like but there are two things. One is like safety risk as well as cyber security risk. And when people are talking about IoT, it will be like purely on security risk. So once you identify the risk along with your functional requirements, then you have a very good base from which you can go ahead and then start your development activities. And as I mentioned earlier, also many of them during the development, they don't even consider security as one key component. Okay, and the incident whatever we have seen occurring in various industries, most of them are actually because of the implementation. Okay, so it is not what to say advisable to say that like, okay, I have built my system but I put into a firewall and I'm safe. That, it doesn't work in that way, isn't it? So security has to be considered right from the development phase itself. So typically like most of these embedded systems are developed using the languages like C and C++. And again, like any other language, these two languages are also not perfect. Okay, so they have their own what to say implementation issues as well, and these has to be considered while developing your applications, specifically your security based applications. So one key aspect as part of your development would be is like start early. So at least use a good static analysis tool and make sure that like you find most of the known vulnerabilities during the development phase itself, and then you have ample amount of time to fix it, rather than you develop, you deploy, and then your system fails on field, and then you're fixing it. That have its own implications. So there are a lot of implications, like it could be commercial, it could be reputation, it could be legal, and a lot many things can actually come up. Okay, so it is better to have a safe and secure development life cycle where you imbibe all these parameters as part of your development. And just static analysis will not suffice. Okay, why? Because like you need to execute your application, and then you need to do a lot of different kinds of tests. Okay, it could be basically to see or prove that whether your system is resilient for any buffer overflows. If it is going to occur, is there any defensive mechanisms? Okay, and the most important thing is basically like data sanitation. This is one of the key aspects which nobody takes care as far as the software development is concerned, which means if you're asking an input from any other interfaces, you're not even going to check what data is going to be it's asking. Okay, so data sanitation has to be there. Their defensive mechanism has to be developed. Okay. And the most important thing is, like, from the hardware level also, security can be imbibed. For example, there are a lot of SOCs and processors which have security, which is part of their chipsets itself, which means there is a secure layer wherein, like, you can have your applications which can run in the secure layer, whereas non-secure can work on the non-secure layer. Okay. And many of these chips also come up with encryptions, and then they also come with, like, safe storage of your keys, or safe data, and so on. So all these things has to be taken into consideration as part of your what to say system development is concerned. Okay, I hope I addressed the query.
Yeah, I think that's quite comprehensive enough. I think essentially, knowing you have to, if you have to use essentially hardware, knowing that you have the hardware that supports whatever functionality you want, and built in a secure way itself is half the battle one, and effectively using it is the next 20-30% of the battle one. I think there's one interesting question essentially on the lines of my next question. Karan, sorry, Nitish is asking, this is for Shinto and Anil both. Nitish is asking essentially, which security standards and framework are followed by the industry for embedded security? And there was one user who asked essentially, how do you secure digital payment infrastructure as well? So perhaps we can briefly touch upon the standards that are there, security for security and safety in embedded systems in, let's say, two, three industry contexts, and then we'll go from there. So Shinto, over to you.
You've been specifically on the standards, right? Yeah.
Yeah. So what standards are there for
Sure.
embedded safety and security?
If you look at the standards game, it's very interesting. Many people probably ignore it, but then as we go, the industry is getting matured. The word standard become very much relevant for us. If you go back historically, the standards-driven development started with mostly in the aerospace industry. I'm talking about 30, 40 years back. And why they wanted standards is, you have a global supply chain, everybody wants to work together, and in future, when you want to have an overhaul of a system, if you had followed a standard-based development, it became pretty easy. So defense and aerospace came up with this approach much early, even before we started thinking about all these things. But in case of safety, legal requirements, these are connected actually. If you maybe I'll try to explain this part. Many people don't understand this part. One aspect is, we all normally see the court cases. Court give a verdict based on an existing regulation in a particular country. The law of the land should support a particular regulation. Now, for such a regulation to come in picture, we need to have standards. So this is where the connect comes in. And if you have standards, a regulatory body can take up those standards and try to enforce those standards. And the court will tomorrow interpret whether the accident or regulation was appropriate. And this is a circular thing that very interconnected also. And that's where actually standards play a major role. Today, people say why we need standards. Without a standard, even you cannot go to the court. Court will just raise their hands, because on what basis I'm going to give a verdict. So that is where standards are important. And predominantly, if you look at standards, whether a safety standard or security standard, you will see a fundamental similarity. Everything is requirement driven, everything is design driven, and then the code is generated out of the design, and tests are done again as per the design. You have already decided what level the test will undergo for a specific standard, for a specific criticality of the device, what you identified, both for safety and security. So it is clearly prescribed that every stage, what minimal things what you need to be doing. As far as you're conforming to this, whether you are in safety business or a security business, you are on the right side of the law. That's the beauty. Even if you tomorrow get into an accident or any other litigations, or somebody sues you, you can you have a solid case to stand up and say, hey, I followed it. My devices are certified. I follow practices, blah, blah, blah. Now, when it comes to standards, sector specific, it works. You have, the ISO 27000 IT security standard, which is a broader thing. Everybody, it's a must to have. Now, even for that also, a basic humus is the best thing. A quality management system is a foundation. Without a quality management system, you can't even talk about an ISO, any of the ISO processes, including a security standard. So that's a baseline, to have a IT security. Once that is in place, a QMS is in place, you have this risk-based thinking, which Anil would have already discussed. The risk-based thinking is nothing but you classify your system into various subsystems, overall a big system, which includes various subsystems, each one based on the impact of safety breach or a security breach. So based on that, you decide, what level of assurance you need to give for each of the subsystems. So all these standards, whether it's a safety standard or security standard, work on the fundamental same principle. It identifies the risk level of the device from a safety angle or for a security angle. I will give you a small one example to understand it. For example, suppose an industrial system, a connected IoT system.
Yeah, yes.
In IoT also, you have the IT-based system, which is you have the office environment, you are using the IT. I'm talking about the OT part, the operational technology, where the PLCs, SCADAs, your distributed control systems, that's where the embedded game comes into picture. So there is a standard called, 62443, originally developed by ISA, International Society for Automation. These guys came up with this standard, again, following the basic standards development process, the risk-based approach. And they have 4 levels. They said, okay, each of these devices, whatever your classification comes in, these are the activities minimum you should be doing. Now, once that got stabilized, even the IEC standards, the people, they also picked up that. You can see ISO standards committee. They're also looking at what these guys are trying to do because they are experts in this area. So every sector has got a sector-specific standard now. If you go to automotive, you have something called, ISO. It was originally an SAE standard, SAE 2144, which is very popular in automotive world today. And in Europe, you want to sell anything today, you need to have a compliance for your electronic control unit, a ECU. That is a basic, subsystem you are selling in an automotive market. So it's mandatory. Without that, you cannot sell anything in the UN Charter European supply chain. So aerospace has got its own standards. These names you don't have to worry. Fundamental principle is it starts with the requirements. You bring in security or safety as a fundamental requirement in your design. Means you cannot do a postmortem, right? Reverse engineering is not possible. That's the problem. Once an accident is done, we can only say, it happened. Once a security breach has happened, it happened. So prevention is better than cure. All standards work on the same principles. As far as you follow the standards, even if, for example, if you look at security space, standards are still evolving in many areas. But if you have basic practices in place, adopted from any of the international practices, 2 things possible. One is you're on the safer side of the law. Second thing is you can gradually build up. Every time when you are doing an incremental step, you have already followed some basic security engineering practice. So you're on the right side of the law, you're right side on the practice, and create that culture in the organization. So people sometimes mistake that standards are against innovation, standards block creativity. These are all misnomers. If anybody who wants to develop and mature his product to a global audience, definitely he should understand the importance of standards.
Yeah, very well said. Very well said. So, I love the last point. Essentially, if one wants to sell globally, then essentially you need to start thinking about standardization and having the best practices baked in from the very beginning itself. So, essentially, for you, the question for you essentially for Shintoji is essentially do you know of any standards that our let's say a company based out of India wants to develop a product and sell primarily in the Indian market, because there's this one point where you touched upon, if you want to sell in the Europe, then you have to meet a specific standardization for ECUs and everything. Is there any standard that is mandated by the Indian government, let's say in the consumer space or OT or IoT space, other than the existing ones that we already know of, 62443 and others, that are mandatorily needs to be followed through regulation by the Indian OEM? Do you know of any such standard in the country?
If you understand the game, I think I'll have to explain how things work in India. We have our national standards body, BAS, Bureau of Indian Standards.
Yeah.
BAS, what they do is they have various working groups working on safety standards, quality standards, security standards. Now, these working groups normally look at what's currently happening in the space, both globally, and see the current maturity level of Indian market. So we probably may not bring exactly what is happening in the global space as well as the domestic market is concerned. So what we normally look at is, for example, if you look at power sector, energy and power sector has identified cybersecurity as a serious threat. Now, in that case, you have the 62443 is mandated as a strategic objective for the country. Other sectors, it would take some more time. But I know there are serious discussions happening. I still remember a couple of years back, I was asked to give a presentation on cybersecurity issues for the automotive sector as a national security issue. Automotive cybersecurity as a national security challenge. My argument was a car lying on the road could be remotely started and it could be used as a terror weapon going forward. So it is a serious national security challenge. Now, my prediction is even though safety started a bit early in the game, security is a relatively new game. But then governments are really serious about it. But then there is a slight glitch here. Globally, safety, when it comes to safety, all the countries are on the same page. When it comes to security, I see some interesting observations because each country is keen in peeping into other countries. So there is some misunderstanding or misnomer the way people interpret and misinterpret. So because of that, if you look at the standards, security standards committees, very interesting observations happen there. Every country will have their objectives, and every country's national security agencies will have their interests. So standards development in security space is a big challenge, right? But then it is progressing very well. It is progressing very well, and as a country, if you ask me, my prediction is globally also security will overtake in the standards game than safety, even though safety started very early stage. Because for a country to survive, for a consumer to stay safe indoors in our own home. I have a classic example. We were now constructing a new home. I wanted a smart room. My wife said, I don't want my bedroom filled with any smart devices. I don't trust any of these devices, Shinto. You might be a security guy. I don't trust any of this. I don't want any of these things. So, government as such, if you ask me, it's a primary responsibility of any government to create a secure home for a common man. I'm pretty sure in the coming years, government will tighten it. Industry guys might have their perspective, but as a consumer, me and you are also a consumer on the other side, we would also start demanding, and that would be a game changer. That every consumer start asking for a secure device, like that what has happened in the automotive space, right? Every consumer is now asking for safety. Those cars which are produced with international safety certifications, the NCAP ratings, they are sold like hotcakes in the market. Same thing will happen in security also. The moment the consumers start demanding, you will see the changes.
Yeah, I mean that's quite an interesting point, right? Essentially, I think most of us now, essentially, whenever we are planning to buy, let's say, something like a water heater or an AC, or anything for that matter, that consumes a lot of power, we look at the star rating. How much stars one thing has? Is it a 3-star rated product or a 5-star rated product? Something like that for security, at least in the context of embedded systems, will be quite an interesting development for all of us. And then, I mean, I agree with you. It has to be consumer driven thing rather than a regulatory driven thing. Maybe supported by regulation, but it has to be largely driven by the consumers. Only then will you see actual real impact of these standards that gets developed and then consumed by the people at the end of the day. A good discussion so far. Anilji, essentially, my next question for you, right, is essentially, how do you, with so many threats that are there against embedded devices and kind of impact that they could create, how do one even approach about building security in the context of embedded systems? Is there any documentation that is readily available for developers to essentially have a look, to see what are some of the best practices when one go about designing the product and firmware that goes onto it?
Yeah, actually, like if you see, like NIST, the National Institute of Standards and Technology, okay, they have guidelines specifically for cybersecurity. Okay, and when you talk about like languages like C and C++, there are security what to say guidelines as well. For example, like you have CERT for C and C++, and for Java you have. And similarly, you have MISRA, which is again well popular in automotive industry and so on. Okay, so there are a lot of these like best practices and guidelines which can be actually followed as part of your software development life cycle. Okay, so rather than closing your eyes and say like my system functions very well, you should also make sure that you dive into it and then identify all the latent issues at the early phase itself. And again, like as I mentioned earlier, also it's multifaceted. So it's not only the software. Okay, so I mean your software can also be at multiple layers as well. For example, like you have a boot, you have your bootloader, you have your application layer, you have your graphical layer, and then you have your communication layer, and so on. So at each of these layers, you need to think about security. So the good initiation point would be is like at least start with the static analysis. Okay, make sure that like whatever code you are putting into on any of these layers are like security validated. Okay, at least you are confident that your systems are like secure enough. But if there are any latent issues, like at least you know those are like minimal, which could be then addressed and through some patches or fixes later on. Okay, so the most important thing is basically like identifying all this issue at the very initial phase itself. So I mean, selecting a right guidelines is also very important. So we have also seen customers like they're defining their own guidelines. Again, like for some organization, like I mean, it could be affordable, but like it is not for everybody, right? So often what we have seen is like most of them leaning towards common guidelines. So one among them is like MISRA guidelines, which has been like well followed across the industries for both safety and security. So I'm not promoting MISRA over here, but again, I'm saying this is what has been actually well followed for both C and C++. Why? Because these are the two languages which has been widely used in all the embedded systems. Okay,
Yeah.
We are also seeing that like some of the embedded systems like bare-bone in the sense like you don't have any operating system which is nothing but you boot it'll directly run your application straight away. And then you have a bigger application wherein you have underlying OS, and then you have multiple layers which is running on top of it. So when additional layer comes in, then again additional checks has to be taken into consideration. Whether you're using there's a concept called as the OOPS, I mean the SOUP, software of unknown provenance. Okay, which means like COTS software. So
Yeah.
we only thought about cards as a hardware, but like this cards as a software as well, which means like left and right, like we take libraries, source
Yeah.
codes, and voice layers also, and set away use in our system without even knowing what is it, without even testing. Okay, so the intention should be, even if you're using some of this SOAP or COTS component, at least you secure, validate them. Okay, at least you validate them, and then you see like, is that secure enough for your application?
Yes. Yes.
And on top of that, anyhow, you're going to follow your own secure life cycle for developing your applications. Okay, so it's all boils down to your development life cycle. And there are like
Okay.
multiple things, like it's not only static analysis, like as I mentioned earlier, like you may have to do first testing, you may have to do error seeding, and you may have deliberately like manipulate certain memory sections and see whether the defensive mechanism, whatever you have implemented, is working or not.
Working
So
on.
it's not
Yeah.
that like you implement a defensive mechanism. You should have a well thought of strategy for testing that as well. Like under circumstances, if such scenario occurs, my systems are capable enough to handle that and then recover from there. Why? Because in OT, like you don't have a provision of restarting your system. Okay,
Yeah. Yeah.
unlike an IT, where like you, in a PC, like if there is a hang, then we'll just restart my laptop.
Yeah.
In OT, like, there is no provision of restarting, and there is no provision of even adding a bug fix also. Like you can't patch like what we patch in our normal systems. Why? Because what if the patch is introducing additional issues?
Yeah.
Okay,
Yeah.
so a lot of things has to be considered in OT environment, specifically when safety gets what is linked with it.
Okay, quite interesting. So, a discussion. One question I think very few of us would have spent some time in thinking into this in the context of embedded systems. So, Sandeep Chowdhury is asking ki what should be the ideal approach for incident response planning in the context of embedded systems. So when there's a cyber incident, essentially, is there any a methodology that is defined to do an incident response in the context of embedded systems? Anil, to you.
Yeah. So say again, like everything like boils down to like how do you log these incidents, and then like whether these incidents can be, I mean, put into open. So if you like Sir does that. So
Yeah.
what they do is like common vulnerabilities or incidents, whatever is occurring, or even the CW also, they also do that. So what they do is like common incidents is occurring across the globe, they document it, and then they also give a provision saying like this is a vulnerability which has been identified, and this is how you can actually address as part of your development system is considered. Okay, so the same thing can be imbibed within the organization also. Like for example, they can have their own incident repository where they maintain that, and then they have to compare that with their risk assessment and identify like all this incident has been was it addressed. If it was not addressed, then there's a gap, so they can actually use it for the continuous improvement as well. Okay,
Yeah.
so again it could be handled internally. You can actually expose them, and if it is, if you're exposing them again, like you have to give a fix before you expose them. So there are
Yeah.
situations wherein like you identified a vulnerability, and then by the time fix is issued, many of those systems were already hacked. Okay, so we have to make sure that like fix first, or at least you have a fix available, and then you report them everywhere.
Okay.
But, but I hope it makes sense.
Yeah, it does make sense. Niharika, do you have any question for the
Yeah,
follow-up
so
question?
yeah. So like, it seems that we are actually lagging behind, and we have to very much to do to cope up with all the security complexes. So and the vulnerabilities. So, but when it comes to startups, so I'm sure we have start audiences from the startups also. So they don't have any lot of resources to cover everything like we have talked about today. So Can you tell up upon our startups that how they should even approach securing their products, Mr. Shinto?
Right question. I'm a startup guy. Way back, I had a business and I understand the challenges of the real startup guy. Uh, to be frank, the biggest challenge is how to pay monthly salary. And the security, design challenges, these are all secondary for most of the
Yeah.
standards. It doesn't even come to their mind. But the sad part is if they don't follow standards and methodologies, with limited resources, a man build a good product. And when he wants to sell it, the customer says, "Hey, I can't buy it because you have not followed any of the guidelines. The product might have excellent functionalities." And then they go back to rework. Even when I've seen that some companies, they get the VC fund. VC backed out the moment the product went to a TUV or UL certification. They said, no, we cannot not even touched it because there's nothing. It is not a certifiable product at all. So VC said, no, we are backing out. So it is good to have an awareness about a design methodology, which Anil was talking about, the risk-based approach, basics of a risk-based approach, and a step-by-step approach. Okay, I have only limited resources. Fine, I cannot invest on expensive tools. That is also okay. But somewhere down the line, even if it's an open source to start with, fine. But you should have a step-by-step roadmap approach. That is where actually, incubation facilities can help. Bringing all these kind of tools under incubation facilities, because a couple of years back, before COVID, LDRA, we launched a program called Certification Mentoring Program. This was based on a study we did, and we found a lot of startup guys don't understand the nitty-gritties. They cannot hire a security expert. So how do we do that? And we came up with a lot of training programs, workshops. But I think that's where actually we need a lot of open content. Content is available, but many times they're very expensive. So I think we need to produce more content, make it available to startups, affordable training, skilling initiatives, again, at an affordable price, because it is very important, because we do send our guys abroad, very expensive. Each of those courses cost lakhs. Which startup can afford to spend 5 to 6 lakh for a person to get certified? Not possible. So instead of lakhs, I think we should start talking about a couple of hundreds or a couple of thousands, where people can afford, or even provide it free. This at least this content part, expertise part. Once that is done, I think we will see a lot more changes. The other side is actually, yes, investing on academia. That would be the big game changer for a country like India. A missing link, because I spend a lot of time with academia. I'm also a resource person for UGC HRD cell for conducting. Every month I deliver faculty development programs. And one of the core aspects which I touch base is this, that, it is high time actually faculties or colleges go a bit disruptive, come out of the traditional comfort zone of curriculum, and develop curriculums which are more industry oriented, and educate both faculties and the startup guys, because very important, because some startups guys ask me, hey, I developed this module, where do I make money? I said security is a universal problem. You can sell in defense, you can sell in automotive, you sell in industrial, nobody blocks you. It's a horizontal opportunity, man. It's not a vertical. Only this thing is bit of fine tuning you might have to do. 95% is same, because it is security. The 5% is the top layer, where you talk somebody's language. So the design principle, whatever you're investing is worth. There is enough money to be made. Startups probably needs to understand, somebody can train them where the opportunity exists, and within our country itself. According to me, there are opportunities exist. Of course, the other opportunities are part of global supply chain. When you're part of global supply chain, many of the OEMs handholds these startups. They give enough training inputs, what to be done, what not to be done. So I would say the answer is 360 degree. 360 degree address this problem from an ecosystem perspective. I tell my colleagues also that we have a small role to play as a LDRA's company. We just play around the code part, but code is only a small element in the whole ecosystem. But
Yeah.
however, bring work with more like-minded people, so that I would say my final call on this is, if you really want to secure this country, this is where we should invest on our
Okay.
Indian designs, Indian manufacturers, Indian products, safe and secure India. In fact, I do have a Facebook page where I run called Safe and Secure India. Some of these issues I discussed.
Okay. Okay, I mean, at least I didn't know that, and I think there's no better way to end the conversation than what you did, what you just told right now. We are running short of time. All the love for more discussions, but I look forward to hosting you again for a longer discussion. There certainly are quite a good learning opportunities for me personally, and I'm sure you would see the same. Audience, some of the audience would say the same. For example, I didn't know 99% of now current compute are going into non-PC world, and then we've also talked upon Anil also told about at least start with the static code analysis in the context of embedded systems and have an Tara assessment done and make that into a secure development lifecycle process, and have teams essentially develop some sort of an interest into the teams in thinking about security from the architectural perspective. And also for the developers in the audience, it's good to see essentially Anilji covered essentially take care of data sanitization, which again, I mean, as an embedded developer myself, I don't think I ever did a data sanitization. I always worry about, okay, is my data coming correctly or is it corrupted, but nothing in terms of injection of the injection of something through the input line. I think that's a good takeaway for the developers out there. And then the last is essentially um, using the hardware primitives that are supported by the processors or microcontrollers themselves will be quite an interesting thing for the developers to do. Not just significantly enhances your security posture of the product, but also more importantly, it will come at a much lower power consumption because hardware is optimized for that. So these are some of the learnings that I had through the interaction, and I'm sure audience have more learning outcomes out of this LinkedIn live session. And thank you, Shinto and Anilji and Niharika for today's session, and I look forward to seeing you all very soon. Thank you.
Thank you.
Thank you. Thank you.
Thanks,
Thanks a
audience.
lot. Thanks, Teja. Thanks,
Thank
Niharika. Thanks, DSCI.
Thank you.
We are very active in LinkedIn. Whoever
Yeah.
wished to connect with us, thank you.
Thank you. Thanks a lot.
Thanks, everyone. Bye-bye.
Bye-bye.
Bye-bye.